Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. So today we are going to continue on Algebra 1. No, I didn't get the calculator. I don't think we need it. Um, the new topic we are going to discuss today is inequalities. So when we say inequality, it means you have two parts or two values that are not equal to each other. So we were dealing with equations, that means both sides are equal. Now we are talking about inequalities, and inequalities come in four distinct favors. Well, there are five, but we are not going to deal about the fifth in this course. We can look at this symbol and we say this is greater than 6 is greater than 3. So where they are open, that's a big opening, that's almost no opening. So the big is greater than the small. That's how you remember that. Or less than, or greater than, or equal. So it can be greater than and it can be equal at the same time. So equality and inequality at the same time, or less than or equal. So exclusively greater than, like 4 is greater than 3, or 7 is less than 10. But sometimes we say greater than or equal, okay? Meaning that, for example, if I say, I will earn today at least $10. What does that mean? At least 10 means 10 or more. See, we say at least 10, which some people think it's less than. No, we say at least. I need to go at least to this level. Meaning if I go higher, that's even better. And sometimes I say, I can spend more than 5. No more than 5 or more. I cannot spend more. So I can spend five or less, but not more. So that would be less than or equal. And we will look at examples of, again, translating the English language into math. And we say, what is at least, what is at most, what is less than, what is greater than, and so on and so forth. So the first are just a quick way to remember, not a quick way, but just to so that you get used to the vocab. So in the first question in part A, say true or false. 6 is greater than 3. Yeah, true. So we write a T. 5 is less than 8. Absolutely true. 3 is greater than 8. False. -2 is less than -5. Here people have trouble. No, -2, you think about it as, here is the 0. This is positive. This is negative. So -2 is here. -5 is there. The one to the right is always greater than the one to its left. So -2 is greater than -5, but here it says -2 is less than -5, so that's false. -4 is greater than +4. Negative numbers cannot be greater than positive numbers, so it's false. -8 is less than -4. Yes, -4 is here, -8 is there, it's to the left, so that's true. Okay, so you have to learn how to do these quickly. Now, let's look at solving inequalities. When it says x plus 3 is less than 4, don't think equalities, think equalities, not inequalities. So solve as if that was equal. What would you do to solve for x? I would have subtracted 3 from both sides. So that says x, now it's not equal, it's less than, so I write less than. 4 minus 3 is 1. X is less than 1. Anything less than 1, it can be 0.9, it can be 0, it can be -15, it doesn't matter. Same thing, here I have x minus 4 is greater than or equal to x. So I'm going to subtract 4, I'm going to add 4, so I make x by itself, and I get x. Notice I have to write greater than or equal to 9 because I cannot change the inequality sign. We will change it in two distinct cases that we will discuss later, but not with addition and subtraction when we come to multiplication and division. Okay, m plus 4. Again, I want to solve for m, so I'm going to subtract 7. I said m plus 4. I was looking at the 4. Okay, so m is greater than or equal to negative 11. In this case, I want to add 10 to both sides to get the p by itself. P is less than or equal negative 8 plus 10 is positive 2. So you see, it's so easy. When we come here, I'm going to divide both sides by 5. So I get Q is less than or equal to 7. You see how easy they are so far. Here it's a two-step because first I want to get rid of the 3. So I say 4h is greater than 48. And then I'm going to divide by 4 both sides. And I get h is greater than 12. Exactly like when we solve a one-step or two-step linear equations. Here, I have to subtract x from both sides because I want them both on the left-hand side. So I get 4x is greater than 24. Dividing by 4, I get x is greater than 6. Very simple. Here, most people will tell you, just distribute the 3 and that. No, you can simplify by dividing first both equations or both sides by 3, both sides of the inequality, and you get x minus 1 is less than or equal to 1 minus x. I want to move the x's, so first let's write it so you can see what we did so far. I don't want x on the right-hand side, so I'm going to add x to both sides so I can delete that. And I get 2x minus 1 is less than or equal to 1. I don't want a 1 here. I want the 1 there. So I'm going to add 1 and get 2x is less than or equal to 2. And finally, I divide by 2. I get x is less than or equal to 1. Okay, 2 more. Here, I need to multiply by 2 both sides. Okay, so this would be 4h minus 8 is less than or equal to negative 4. Just multiplied everything by 2. Then I'm going to add 8 to both sides. I get 4h is less than 4. Divide by 4 both sides. Sure enough, I get h is less than 1. Last one on this page, or on this exercise, I have to use a common denominator. So the left-hand side, I take a common denominator of 20. Notice 4 and 5 don't have anything in common. 4 is 2 by 2, 5 is 5. So now I can multiply the cross. I say 3x times 5 is 15x minus 2x times 4 is 8x is greater than or equal to 14. 7x over 20 is greater than or equal to 14. Notice most people will multiply by 20 both sides, but why use large numbers if I see that 14 is 7 times 2? So I simplify by dividing both sides by 7, in which case that would be 2. So I get x over 20 is greater than or equal to 2. And finally, I multiply both sides by 20. And I get x is greater than or equal to 40. Okay, so we are done with those. We did them quickly. Now we are going to see how we are going to draw these and read a graph. This is a simple graph of one variable, x, so we don't have x and y. We'll go over that when we have two variables in inequalities, and we see how we solve those. But this is telling you greater than, x is greater than -3. You locate the -3. And then if it's great that, then we draw an open circle. Open circle meaning there is a hole at -3. There is nothing. So x cannot be -3 because -3 is not part of my graph. It's a hole. Think of it as a whole. Just the 3, not the 299, the -299 or the -3.01. No, just the 3. And x is greater than, meaning it's moving to the right. So you draw an arrow. It's a ray going to positive infinity. So anything in this direction right after -3 at -2.99999 is okay, but not -3. X is greater than or equal to 2. Oh, so at 2, there is a closed circle, meaning, yes, it can be 2 because x equals 2 is okay. And greater than, so I draw it to the right, meaning it goes to infinity. It doesn't stop. It's very simple. X is less than, meaning to the left, or equal to 0, meaning the 0, I have a closed circle. So I can have, x can be 0. And moving to the left. Oh, what is that? That's an interval that is between two values. X is greater than -1, so I do an open circle at -1. It's greater, meaning it's moving to the right, but it's not going to go all the way to infinity because it cannot reach 3. It can come right before 3. So I have an opening here, and that's a segment that goes between -1 and 3, but not including them. Okay? So if I don't have equal, I draw an open circle. If I have equal, I draw a closed circle. Greater than is to the right, less than is to the left. If both are there, so I am to the right of -1 and to the left of 3. Very simple. How about this guy? -5 is included because there is an equal sign. So at -5, I draw a closed circle. At +5, I draw an open circle because it's less than 5. It stops right before 5. Of course, if you have a straight edge, that's better. And you say, here is my interval, and I couldn't draw a straight line. -2 is open. +4 is closed because I can reach 4. And I draw a line between them. Very simple, you see? Oh, when I say and, what does that mean? It means I may have 2 different intervals. Look at that. 0 is not there. X is less than 0, but not equal to 0. But it's not between 2 points here. It's from -infinity to 0, but not including 0, and x at 3, closed, and going to infinity. So that I have 2 intervals. X is greater than 4, going to the right, and x is less than or equal to -1, to the left. So these are the inequalities, how to draw them. Now, how do we read them? X is less than 4. That's easy, right? It goes to negative. We don't say from -infinity to, they don't ask you to write it in interval form. So all what you have to say is x is less than 4, not less than or equal, because that's an open circle. This one is x less than or equal to 4. See the difference between these two? The 4 is in the interval, the 4 is not in the interval. X is greater than or equal because to the right it's greater than, closed meaning equal to -1. X is greater than or equal to -2, less than 4. It's one interval, but it's open on the right, closed on the left. Here, x is greater than -4 and less than or equal to 0. And finally, this one is x less than or equal to -3. And I think you got that. These are easy examples as an introduction to inequalities. After that, we are going to have a system of inequality, linear inequalities. So two inequalities, maybe one of them is greater than or equal, the other is less than, but they have x and y. So how do we find the area or the solutions that satisfy both? That would be our next lesson. Thanks for your time. Hope to see you soon. Goodbye.